To advent of code in Liquid Haskell. Got about 30 seconds to go before today's puzzle drops. You can see I still haven't filled in day 19. I was working on that a little bit. I decided rather than try to build a better depth first search, I'm going to throw it over to a mixed integer linear solver. And so I'm writing the code that uh, establishes all the constraints, and then once that's done, I can dump it out in Cplex format and figure out the Haskell code for running a subprocess, which I've never done before, and probably parse its output. But let's look at day 24. Hopefully we'll have an easy one today. I forget whether previous days 24 have been really hard or fairly relaxed. Mountain is covered in snow, sort of like Minnesota. My outside is covered with drifting snow too. Okay. All right. We need to dodge the blizzards. And we need to do so in the least amount of time. Okay, so this suggests this suggests an A star search. Um, how big is our puzzle input? Quite large. Well, this is gonna be a challenge. So we need to track all these individually because they can cross. So there's not I'm just wondering if there's some optimization possible here. Um, so obviously we could compute all the possible blizzards in a cycle and then calculate our path through there, rather than recalculating the cycle every time. So I think that's the right thing. If we think about this, sort of three-dimensionally, then all we care about is the empty spaces, of which there are relatively few. So if we plot out all the empty spaces, then our A star search should be pretty straightforward. So that's our plan. We're going to simulate the snowstorm, record empty spaces, at each time interval, and then do an A star search through that. Sure. All right, this is day 24. There's a real input. Let's get the nice example they gave us. Oops. All right. So we start in the upper left-hand corner. Yeah. You and the blizzards act simultaneously. So we have to end up in a space that's empty. It doesn't matter. Can we walk? Yeah. So that you see here, we walked through a blizzard. If it was not a discrete simulation, we swapped spaces from there to there. So it's only at the ticks that it matters. All right. Pardon me. Oh, it's day 23, not 24. My mistake. Sorry. All right. No, it's 24. Yes. Why is? Oh, okay. I thought this was the default because I had refactored everything but the solve call. All right. There we go. Okay, but I do from day 23 want the parsing code. Where is it? Parse input. All right, sure. Let's grab our coordinate code. Except we'll need a 3D coordinate eventually. I should put this in the library. All right. It's not too late, I guess. Okay. And from day okay, we need an orientation and maybe I had a better version of this around somewhere. Okay, so we're gonna need Blizzard. Blizzard. So Blizzard has a position, which is a coordinate, and a direction. So we might want to define a subset that has a subtype of those with the coordinates are in bounds later. All right, let's do we need to get the size? No, we can just count that separately. All right. So we're gonna need I guess it's just gonna be a list. I'm gonna do this using two. I'm wondering if we can do it with if there's a list function. So is there one that gives the indices and the so want a pair of int comma a? Nothing like that. No. Okay, so we can zip it with. All right. So we're going to go from a character to maybe orientation. So east, west, north, and south. Those aren't the right types. I'll fix that in a second. So we're going to all right. Building from the inside out. So we're going to zip 0 to 0 to the length of row with the row. So that gets us x coordinate comma character. All right, so we'll fix this instead. So we're going to take those pairs. Oh, okay, and then we're going to turn that into a blizzard, just a blizzard. There we go. Okay. So we got our zip. We're just going to map parse direction over that list. And then, parse direction of y. And we want map maybe, because we're going to just throw out all the nothings. Okay. And then we're going to do it for the next row. Great. So let's um all right, so let's build a map of the valley. So that's got an X size and a Y size, and it's got a set of blizzards. Blizzard, there we go. Should I call this something else? Yeah, let's call this parse blizzards. Does have two Z's, right? It's already looking funny. All right, we're going to so that gives a valley with X size equals length header rows, which Liquid Haskell will complain about it. All right. So why isn't Liquid Haskell complaining at us yet? I'm just going to tell it that the number of rows has non-zero length. All right, so let's define our type for coordinates in range. So for a valley, oops, I need to copy this into Liquid Haskell. Okay, we're going to tell Liquid Haskell that the type blizzard in range for a valley is a blizzard with X chord of blizz position of, oh, I hate this already. Pause beater of B okay is greater than or equals 0, and X chord of B pause B is strictly less than. Okay, it's more complicated than that. So the first row is the mountains. We're not allowed to have a blizzard there. The first column, I mean, and the last column is also mountains, and we're not allowed to be there. So this actually is more restrictive. Okay. So every blizzard in the range, every blizzard here has to be it's not gonna work. I gave it for the whole valley. So okay, so this should be a blizzard in range X size, Y size. All right. Oh, did that. Did that in the wrong place. Oh, I didn't change it both places. Okay. So there's a little problem here, which Liquid Haskell is telling us about, is you didn't do anything to guarantee that these were in range. So we will. Okay, so we can filter while we're parsing, or we can filter elsewhere, or we can prove that this is always the case, which is difficult because we started at 0, so we'd have to guarantee it somehow. So let's just let's validate the input. Blizzard in range X, Y. Now, it would be awfully nice if we could use filter, but we ran into this before, that the type of filter is not strong enough for that. So we give filter a predicate. All it knows is that the list is of less length and it has the same type, which is not really what we would like. We would like it that for every member of the list, this predicate returns true. But that is a higher order function. So we're going to write our own filter because that's what we do in Liquid Haskell. We reinvent the world nightly. All right. Empty list goes to empty list. Otherwise, if b plus b less than y equals 1, then b and filter the rest. Else, just filter. All right. So if we use filter blizzards on that, blizzards. Oh, filter blizzards of. Oh, we can't use the X size yet. All right. Looks like it's happy. So let's. So we need to simulate the value from one time period to the next, and we need to. We need to extract the empty squares. And so we can just do that, both of those as lazy lists, I think, using our good friend iterate. All right, so All right, next blizzard first. No wonder I'm so slow. I keep typing every function twice. Okay. Okay. So can I do that? I don't know if I've done that before, but I don't see any reason it shouldn't work. Um, okay, so we've got a and they never change direction. Oh, okay. So if we represented this as a big bit mask, we could just shift the bit mask of everything going in one direction. And that would be a lot more efficient, and then we could or them all together. Uh, there's not a technique I know how to do in Liquid Haskell, but I bet it's a really big speed up. So is there any benefit to using the same idea? We'd have to do a lot of math to create the bitmaps of the right size. Um, we could create vectors though. So the operation of shifting the matrix over by one does not seem particularly efficient. So I guess I'm going to stay with my plan. But I now know what I would be doing in a different programming language. And so I hope we're not too much slower because of that. And so part of the reason I'm calculating these separately is so that, no matter how bad the calculation of the blizzard is, we only have to do it once for, however long the simulation runs. All right. So if nx is less than 1, then nx equals, we need the valley size here. Is this right? Let me just make sure I'm not doing an off by one error. So 0, 1, 2, 3, 4, 5, 6, 7. So if it's 8, it needs to be 6, which is what we did. NX greater than okay. Obviously, we could have written that as a higher order function, but with only 2 uses, doesn't seem to make a lot of sense. Okay. So let's this had better return a blizzard in range with x size v and y size v. All right. Close parenthesis. The name of this constructor is BZ. Only return 1. Oh, I gave it the same name. All right, so I'm a little surprised it can't give a better type to. All right. +1. Those are not -1s. Those are just 1s. Still not getting it. All right, let's. Take a closer look at this. It's possible I still got it wrong. Greater than should be fine. Yeah. Oh, okay. We didn't tell it any bounds on the size. So let's say this has to be at least 3. Okay. Right, because we could have specified something impossible before, and now it should be possible. But it's still unhappy with us. I wonder what happened. Let's try the experimental flag, which I don't know if it works. Counter examples. Counter. Well, I really don't like that it doesn't yell at me for flag it doesn't understand. I don't know that I've got a version that supports it, but it certainly did not work. All right, I'm gonna preserve this version and try to do it case by case. All right, so if nx less than 1, then if ny less than 1, and they can't both be true, but expressing that would be complicated. X size v minus 2, y size v minus 2. Okay. NX greater than x size v minus 1, then do all that over again. Just slide and write it this way. It's a gigantic pain in the butt. All right, so now we broke it into 9 cases. And if Liquid Haskell is unhappy, then it can tell us which cases it's unhappy about. All right, very good. It doesn't like this one. It's less than 1. Okay. Okay, this needs to be greater than or equal to, I bet. There we go. All right, that was probably the bug in our original code too. Uh, okay, so now that we now that we got Liquid Haskell to give us right answer, then we can go and check our compact one again. All right, looks good. Hurrah, we caught a bug. All right. And blizzards equals map next blizzard v. That gonna give us problem over the blizzards of v. Hopefully you don't have to argue about it that things that are equal to the other thing are equal to itself. The SMT solver should have that well in hand. All right. So let us use a set for the next part. don't like using the set because our ability to reason about it is limited, but maybe there's something we can do here. So what we'd like to say is that it's a set of coordinates such that that are it's a set of special coordinates that do not appear in the list. So not appear in the list is difficult. So I did something. So here's an example about reasoning about things in a list. And what I had to do is define a member function. Here's what we want to prove about. The theorem we proved is not part of the definition of maximum at all. It's a separate theorem. And it says, given a list and an element and a not necessarily an elemental list, a value of the same type as the list. If X is a member of the list, then the maximum is greater than or equal to X. Right, and so this is a proof that proceeds recursively, but we couldn't express that all in one set. So we could maybe prove that a theorem like that. But I don't think we can express it as the type of the coordinate. Could we define a predicate? Can predicates be recursive? I don't want the flag reference. I want the spec reference. So if it's a measure, it can only have one argument. Yeah, I don't think we're going to be able to do something, but I'm not particularly satisfied about our lack of ability to do so. All right, so what's the best way to do this? So we could create a set of all the coordinates that should be inside and subtract out the ones in the list. So we don't have the blizzards in a special order. So I think I think we're just going to have to do it like this. So this is going to be point xy for x from 1 to x size. Oh, well, we can ensure they're inbound. We only defined it for Blizzard in range, but we can define a chord in range too. In fact, we could have defined the old other one in terms of this instead of copying and pasting. All right, so um, right, so that's the type we want. We're not going to get it like this. We're going to have to use our special int range function. All the way back from day 8. So you notice we just have to assume that it's the type of this is correct because it's based on enum from then too. So we could write a version where we actually proved it was correct by doing the iteration ourselves. Okay. So now we have to okay. 1 to x size valley -1 in steps of 1. Okay, so we're going to okay, I wanted to use the list monad, so we're going to take our list of y coordinates and call row on that, pipe that I really should learn how this is pronounced, what the actual name for it is. Now, but we're going to take the list, we're going to call row on each element of the list and concatenate all the lists, which is what we want. I don't know if there's a better way to do that, but okay, so let's before I go further, let's see if it agrees with me. It does not. All right, so let's break this down. So what we say is row goes from ints to it goes from an int such that y is greater than equal to 1 and y is less than y size minus 1 to oh, didn't like my specification. Didn't not map valley. Okay. It doesn't think v minus 2. There we go. All right, caught another off by 1 bug there. Hey, it passed. Great. So can we get lucky here? So if we start with all spaces, which has the right type, and then take the set difference of, do we know about difference? Yeah, we do. All right. So this is a set dot from list of map. What do we call it? B pause. Yes. All right. It likes that as it should. You know, we took some stuff out. Doesn't matter what we took out. It doesn't change the type. For union, that might be another matter. What does Oh, interesting. So it says, so if we tried to do union on two different refinement types, it would I think what this means is they would go to their common ancestor. That might make an interesting experiment at some point. All right. So let's calculate the sequence of okay, we need an assumption about iterate. My assumption is it returns at least 1,000,000 entries. That is a true fact. So open spaces. All right. I think we need something new here. We need to say tell that next value doesn't change the size. So this returns a value of the same size. So x size v2 equals x size v, and so that way we know that I don't like any of the names. This can be the infinite list of times, and then we can index it by which time we're at to search for open spaces. Uh, so we're going to map open spaces over iterate next valley on from our starting position, which is V. All right, something's unhappy. Typo here. I'm not good at closing the specification braces yet. All right, a bunch of warnings, but we're good. All right, let's try this out on our test input. We should be able to do this. So okay, so we're going to Advent to Code is a sequence of programming puzzles. Let me pull up the website. One for each day in Advent, the 1st through 25th of December. So it's adventofcode.com. There's a puzzle for each day. Each come in two parts. You can uh, solve it in whatever programming language you want. You just have to produce the right or no programming language at all. You just have to get the right output. So there've been some programs that don't require code, but usually people use it, like me, to have fun programming. I'm using it to learn a new programming language I don't know well called Liquid Haskell. Yeah, it's not it's the same structure, but your input is different. So this input is not the same for everybody. So it's yeah, it's run by Eric Wastel and a group of other volunteers for several years running now. Thank you. Okay, so where was I? Okay, we're gonna print the. We're gonna have to carry our cheesy assumption about the list size everywhere. Maybe. Yeah, we may have to improve this to say it's at least this long if we want to index into it. But for take, we don't need that because take, if it's too short, it just uh, takes as much as it can. So in the example, we need to go 18 minutes. So let's try that. Day 24 example. All right. I'm sure you'll find something to complain about. Oh, we didn't use. All right. This could be better. But let's see whether we have the right results. So in the initial state, so there's 3 comma 1, 1 comma 2, 3 comma 2, 4 comma 2, and 3 comma 3. All right, great. That should be gimme. How do I fit these both on the screen? There we go. So here we've got 1 1, which is good because we're sitting in it. 4 1 6 1 2. Hello. Oh, well, thanks for the follow. Sorry, that noise startles me all the time. 2 2 3 2 6 2 3 3. Yep, 6 3, and this should be 4. 1 2 3 3 comma 4 and 4 comma 4. Yep. All right, and then the last minute, the open spaces should be 2 comma 1. Yeah, 4 1. Yep. 4 1 2 2. We're Oh no, they're just scattered around. All right. Oh no, I picked the wrong number, so I'm off by one there. So we need to look at here. So no, it looks like I have a bug. All right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is minute 17. All right. 2 comma 1, 4 comma 1, 2, 2, 4, 2, 5, 2. Yep. 1 E. Nothing else in that row. 4, 1, 4, 3, 4, 4, 4, and 6, 4. All right. Looks good. So now after an hour and 20 minutes, we are half done. More than half, I think. So now we need to do our A star search algorithm. So this is a particularly difficult puzzle. Um, it's made more difficult by the fact that I'm not an expert in this language yet. But yeah, this puzzle is doing a lot, and it's asking if I put up the input again, it's asking us to do it as a fairly large example. So we have to write a fairly efficient algorithm to solve it in time. That's often a problem with these. Is even if you write the code, you might write something that on the real input doesn't work. All right, so let's define. Okay, so we need to define a state covering where we are, and that's going to have 3 coordinates. So let's say um, so the elves have a elf position, which is a coordinate, and the e time, which is an int. All right, so let's think. Okay, so what I want to do is use this time as an index into this list. So Liquid Haskell is going to yell at me if it's past the end. So I guess I'm going to use the same cheesy. All right, let's define a type. So the type of infinite list of chords. It's not really infinite. Of V. Oh no, of all right, that's not infinite yet, but I'm worried about using X size and Yeah, it's yelling at me. Cannot unify main.value with func blah de blah de blah. All right, so we'll go with do what we did before and use X max and Y max. Wow, it's really unhappy with that. Oh, I typo. That helps spell everything correctly. Okay, good. All right, so now let's make it a big list. So this is a list such that len L is greater than equal to 1,000,000. I hope it doesn't take us more than 1,000,000 steps. Okay, great. So we have to put the same bound on the time. So we're going to tell Liquid Haskell that this is a natural number, but it's less than or equal to 1,000,000. So which means we're going to have to check that as we go. All right, so to do a star search, we need two things. Well, a bunch of things. We need a heuristic for how long is it going to take us, and we need a method to generate the valid next neighbors. Okay, there's a little type we can use. So all right, so let's write the specification first. So this is going to take, okay, this is going to have to take a valley to get the size. Yeah. All right, so to use this, we have to prove that we're already in bounds, and it's guaranteed to continue to, I gave it twice. It's going to verify that that continued to be the case. Which might mean that we can only do an empty. Okay, so we need not just the valley, but we need our infinite list of open spaces. So this has type set of coordinates, and we'll use our type alias. Boy, it'd be really nice if we could just refer to V by name. I don't really know what is preventing us. Okay, valley, open spaces, and our current position. All right, so if time is bigger than our artificial limit, then we can't go any further. It's not particularly practical reason is there. That's just because Liquid Haskell doesn't really have a type for infinite lists. I created one, but I don't want to pull it in and mess with it some more. So, but this just keeps the checker happy. All right. So else we can stay here. We can move in one of the cardinal directions as long as that space is going to be empty in the next time period. So so let's write a function to check that. So nx has got to be greater than 1, and nx has to be less greater than or equal to 1, nx is less than x size, and nx and y greater than 1, and ny less than. I think this is the third time we wrote it. We should have defined a function. All right, and the point nx and y has to be a member of open spaces at time t plus 1. Point. Okay. So we're gonna create a list and filters. Here's our problem with filter again. Crud. All right, we're gonna do something a little cheesy. All right, hang on, I know. So we're going to create a one element list if all those passes, and it's going to have the new elf with point nx and y and time +1. Else an empty list. So then we can do valid and empty x +1 y and just append all these 0 or 1 element lists together. So I'm going to introduce a slight bias towards moving left and downward. That the order these appear in is the order they'll get explored. So I think it'll be a little better to bias it slightly like that. Okay. Time. Oh, all right. All right, I'm gonna fix that here. There we go. It's just an off by 1. I let time go all the way to 1,000,000, but 1,000,000 is not an index in the list. All right, looks good. So that's our move generator. Now we need a heuristic. Which we're just going to use Manhattan distance. Valley, Valley elves, which is our estimate of how much time it will take to get to the end. And so it can be no less than getting 1 square closer each time. So let's grab our Manhattan distance. Oh, that's on voxels. We don't like that. Didn't we define it on coordinates? I guess not. All right. Okay, looks good. And the destination is the elves are allowed to be in a larger range. Elves are allowed to go. They're still bounded by the walls on the left, but they can go to y coordinate 0. All right. So we better fix this. Okay, I'm just gonna do this to the cheesy extra case or two here. So if nx equals 1 and ny equals 0, then that's fine. That's our starting position. I can't see why we'd have to move back. That seems like a bad position. So if nx equals so those are the only 2 points that are on the borders of the valley. Let's just double check this. Yeah, so 1 comma 0 and 1 0 1 2 3 4 5. When it's 6, so that's minus 5 6 7. So this is 6 and this is 5 0 1 2 3 4 5. Yes. All right. Okay. So we just agreed that the start position is x size v minus 2 and y size v minus 1. Hiding, not excluding. Okay. Absolute value is already defined, but not point, it's coordinate. One of the things I don't like about Haskell is it doesn't seem to be possible to give a type and its type constructor the same name. And sure, they're different things, but it means you're always having to come up with 2 names, and usually one of them is silly. All right, so that's our heuristic. Now the hard part, we need to write our A-star search. All right, so it's going to take a valley. So I'm just wondering, is this going to be the function that we recursively use, or is it going to be something else? I think it's going to be this. So in this case, we better take our no. Let's do this better. So it'll be a high order function. So we'll take our neighbor function. It'll take our goal state. It'll take our heuristic function. And we can just query all those with the value argument. Oh, but then we need to give it the infinite list. No, we don't. We don't. That's the point here. Is once we give it these two arguments, then it's just a function from elves to list of elves. All right. Okay, so those are the excuse me. It's very dry here, and my sinuses are running amok. All right. So to do A star, we need to have a priority queue. And which state we're currently visiting. Now, an optimization would be to remember positions we've. I was gonna say we need to detect cycles, but it's not clear how we would. Hi, Epsilon. How are you doing? All right. So next, neighbors, goal, heuristic, our heuristic function. Okay. I think I'm just doing the final part of part 1. And this is, I think, the first time we've done a star search. So I need to figure out what I'm using as my priority queue. And I think it is going to be pair of the heuristic value. Gosh, it's been a little bit since I implemented a star. Let me just make sure I'm on the right track. How did your day 24 go? All right. Well, good. Congratulations. Sub 1000's always respectable. Back in when Advent of Code first started, I could occasionally get onto the top 100 list because it was not nearly as popular, and I was just throwing things together in Python. I think the puzzles maybe were not as hard too. But yeah, I gave up on that several years ago. Good. I'm impressed. All right. So our priority queue is going to be a set with int and else. So I don't think we have to worry about duplicate detection because our cost increases one every time, right? There's no way to arrive at the same position from two different costs. It's going to be at a different point in the blizzard cycle. So I hope we don't run out of memory. I'm debating whether I should make some effort to return the actual path. I can add that. I can add that to elves if I really want to, but that's going to cost us a lot of memory. Okay, so if we don't need current, we just need the priority queue. Okay. And there might not be a path. Okay, so if the priority queue is empty, then we didn't find anything. So we're gonna extract the min. The min cost is set dot. Oops. Find min. We could use lookup min and do both at once. Sure. Okay. You don't care about the priority. It's an elf. Okay, so if goal E, then hey, we found it. All right, else let nn equals the neighbors of E. And then we need to, I forget, to have a bulk insert. No, it's got union. All right. All right. So those are the neighbors. We're going to apply the heuristic function to them. So E goes to heuristic E comma E. Let's not confuse ourselves. Okay, so we're going to do A star search. And the only thing that we're going to update is the priority queue. So that's going to be, we need to extract, we need to remove the minimum. Otherwise, we're going to be very unhappy. Delete min. Go away. Yeah. Oh, we can do delete find min. Very fancy. Except it doesn't check whether the set is empty. Okay, min view. Okay, so it's our elf with the elf's priority and new queue. So we're going to do new queue union from list neighbors with heuristic. All right. It says Liquid Haskell's complaining that we don't know that terminates. We're just going to tell it, don't worry about it. Proving that it does terminate, it would be quite hard indeed. Maybe not so hard because time's always increasing, but we didn't actually call that. I'm going to do it here. Set out from. Oh no, no, I didn't get that right. new queue set union with all right. So all right. News. Where did the valley come from? I'm very confused. Oh, okay. We called this H. But this is wrong. This is wrong. It needs to be heuristic plus the path so far, which is e time of n. Yeah, it needs to be f of x plus h of x. Oh, all right. So to use that, we need to define an order on else, which I don't think it matters. Okay, so elf of coordinate and time c1 t1 alpha coordinate 2 time 2. So we're just going to compare them as if they were pairs. The order does matter for which gets extracted first when they're tied on heuristic, but it's the minimum. Do we want to put time first, I guess is what I'm asking. I mean, the order in which we break ties could matter if heuristic isn't good enough. What I'm hoping is that the space, the connected space of empty, I'm hoping that the paths through empty non-blizzard spaces is sparse enough that it doesn't really matter a lot what we do, because the search space is deep but doesn't branch a lot. So I guess we will find out. All right. I think we're done. I think we just need to put them all together. So okay. So oops. All right. So the start is in elf at 1 comma 0 at time 0, and our neighbor function takes the valley and our list of open spaces. Next moves, there we go. Neighbor f. Our heuristic function, neighbor. Our heuristic function is heuristic valley, and our starting queue is, doesn't really matter, 0, start. Set dot singleton. Okay, so one thing we can do to debug this, if necessary, is change its return type from a maybe to a list. And we can just dump out all the states that it explores. I don't see a good way to do both in the same function. So when I've done this before, I just copy and pasted it. Okay, so we're going to call a star search with our neighbor function, our goal function of if x size v minus 2 and y, oh, we don't need an if, y equals y size v minus 1. Yeah, all the way at the bottom, 1 off from the top. Okay. So we need our goal, our heuristic function, and our start queue. I don't expect we'd ever hit the nothing case, that it would just run forever. Constructor for elves is just E. All right, let's try that out on the example. Helps if I spell things correctly. Oh, what's another bug up above? Show T. Oh, elves needs an equality. I can just do deriving. Default equality is fine. Default comparison probably would have been fine. Hmm. Interesting. I'm not sure why that is the function it's complaining about. Let's it's so odd that it has half of the type. Okay, so the next move requires that the elf be in range. Okay. So let's try writing a specification. The problem is we may actually need the valley to write it. I was hoping not to have to do that, but all right. All right. So let's give refinement types to all these. Okay, so this is not just any priority queue. Is actually a set of pairs int. We could come back and argue that they should be positive. We didn't guarantee this was the case here. Maybe that'll become important. And this is but the important thing is the next argument is a elves in range of x y size v. So do we have to? We may have to annotate these similarly. I'm hoping what this will do is tell us either fix the error or tell us more clearly what went wrong. It did not do the latter. All right. One problem with using this language for is that the compilation times get longer and longer as the times get longer and longer as the program gets longer, which is a good argument for chopping it up into small files. All right, what went wrong here? There we go. Okay, that's progress. So let's tell it that start is in range. And that start queue is of this type. Oh, it doesn't believe we're in range. So X size V should be at least 3. We specified that. I think that's probably the problem, is that knowledge does not get from point A to point B here. Okay, greater than 1. Yeah, it's got to be. This should be greater than or equal to 3. And 3 minus 1 is only 2. What if we say it is all right, I guess we got to recheck it. If X size V is less than 3, then it should never happen. So it can prove that those can't happen. Do I have an error in the check? It's entirely possible. Oh, no, that did it. All right. So it says we got there on time 18. All right, let's try it on the real input. See what happens. Hey, not bad. Is that plausible? Yeah, 30, 36. Yeah, it's 100 wide. All right. Hurrah! Start to the goal, then back to the start, then back to the goal. All right. Sure. So we can do this. We did a couple things right that will make it easier. Okay. So all right, let's say that this is in range if it exists. We shouldn't have a problem proving. So we need, all right, let's refactor this to goal at end. Um, and goal at start. So x equals 1 and y equals 0. Okay. So now we just need to run it 3 times. With different start states. And since the time is already part of the start state, we just need to take the time at the end and continue using that and use that as our new start time. So let's refactor this into I guess we don't. All right. So let's do that to goal. And we need a new heuristic. Okay. I'm just wondering if we can package this up in a nice way. It's not going to save us a lot. I guess it would save us a bunch. Yeah, let's just do part 1 and part 2 together. Okay, so what we're gonna do is we're gonna print the goal, and we're gonna do okay. So we're gonna call part 2 with um, okay, we're gonna call it with the valley, and with our infinite list that we pre-computed. So in Haskell, that's just a list of coordinates, a list of set of coordinates, and we need a new start state. Okay. Okay, so part 2 of V and S and start. Okay, so the neighbor function's the same. The goal is at start. Our heuristic function is heuristic at start. And our starting queue is a singleton. Should we reset the count at 0? It doesn't matter. It's all relative, I guess. So it'll be clearer. I don't think it matters. All right, what is it so unhappy about? Equations have different numbers. Oh, there we go. Valley S goal. And then in part 3, we're just gonna, oops. I really hope Liquid Haskell doesn't take exception to our use of IO here. So this is awful code, but I feel like it would take longer to refactor. So part 3, same arguments, and we're gonna do goal at end and heuristic. The elf carries its own type, and we don't need to do color cells. So yeah, maybe we could we could write this as a sequence of goal and heuristic, and just chain from one starting point to the next. So if we're gonna do this a lot, then let's actually uh 54 minutes. Sure enough. Let's see the next part. Okay, looking good. Boy, can you imagine? I'm really curious how they created the puzzles that were guaranteed to have answers. Hurrah! We did it. How did we do? Hey, pretty good. I think that's our best ever. Yeah. Not in terms of time, certainly. All right. What time is it? Um. So, well, if you stayed with me this long, Merry Christmas. It is now New Year's Eve, where I am anyway, and not New Year's Eve, Christmas Eve. I have day 19 to do. I don't think I will have a lot of time to work on it tomorrow, so I'm tempted to make some progress tonight. So I think I'm going to switch over to that. Uh, and so we could clean this up in the way I suggested. Um, yeah, proving termination a star search would be quite difficult because it might not terminate. It doesn't terminate. In fact, if we're just led into a loop forever, we'll just keep exploring the loop until we hit. I guess so. We have a maximum time, so it's not completely infeasible to prove that we'll terminate one way or the other. But the specifications did good today. They found some bugs. I had to rewrite a function so it would tell me where the bug actually was, but I messed up greater than or equal to versus greater than, and Liquid Haskell found that bug. So yeah, this worked pretty well. All right, so let's open day 19 back up. Okay, so what I decided to do is cheat. Uh, by which I mean I'm gonna phrase it instead of doing depth first search and doing all the optimizations, which work for most people. I'm going to phrase it as a mixed integer linear program, or not really mixed. They're all integers, an integer linear program, and give it to a solver and see how that does. Which has its own set of challenges, but it's less frustrating for me than trying to do the DFS tuning. So we'll see. All right. So our linear program has this basic structure. We've got a set of variables for robots and resources and purchases at each time. Uh, we need to make sure any purchase we selected we can afford. We need to increase the number of robots by what we purchased, what we built. We need to increase resources by the amount the robots produce and reduce the cost of any purchases. So um, So I came up with a cheapo intermediate representation in terms of constraints, and we'll spit that out as Cplex for the solver later. So right now we're just making sure we have all the constraints in place. So there's our initial state. There's that we can only build one robot at a time in each time period. The build choice we pick has to have enough resources, and then we need to do the relationship between time. So resources first. So these are equality clauses. Problem with coming up with your own language is you don't your own domain-specific language within Haskell is you forget what everything is actually called. All the disadvantages of learning a new programming language on every program. All right. All right, so we've got a list. The first thing is okay, 1 times the old value of the inventory, and then minus 1 times no, yeah, minus 1 times so this was our bound, and we need to do all these terms. Okay, so if we build an OR robot, then we gotta pay the cost for the OR robot. If we build one of the other robot types, we got to pay those. So all those are negative. Then we add in the robot var. We're going to change this to material. All the robots produce. And that gives us in var of mi plus 1. Okay, and we do this for I is 1 to max time minus 1, because it represents pairs, and we do it for the material we do it both. Sure. Oh, no, we can't. Okay, so we do this for each time period. God damn it. All right. So those are equations for resources, and then we need similar ones for robots. That otherwise the linear program will try to We'll try to create robots out of thin air. Okay, and this one we can do. Okay, so 1 times robot var mi and 1 times build var mi equals robot var mi plus 1, for I is 1 to max time minus 1, and m. How do we do this? Can we just give it a list? Yeah. All right. So then the next minute is next robots plus next resources or okay. What's it unhappy about here? Parse input. Okay. There's the list. Okay, what's going wrong here? Oh, there's a comma there. Okay. All right. I think that's our program. So let's try printing it out. Um, did these in a bad order. So we got 24 minutes. Okay, let's do. Got to do a bunch of those. Okay, that is day 19. Okay, lots of problems where I cannot spell obsidian. Okay. All right. I got these in the wrong order. Just flip them around. Uh, Okay, well, that looks like a linear program of some sort. Let's okay, let's write a library that writes Cplex. So let's actually take this stuff. All right, so this is going to be one big ass append. Okay, so we're gonna say I'm gonna pull up this. Where did I have that? All right, I've got the GLPK module manual over here, which has a documentation of this Cplex format it uh, understands. I don't know if it's the same as other solvers understand. Okay, so we're going to maximize. Um, okay, we're gonna have to find that. Then a new line. And do we have to give it a name? Okay, no, we don't. Okay. So maximize, and then the next section is subject to. Yep. Subject to. Okay, and we're going to do unlines of map. All right, good. Unlines. Okay, and then the next section is binary for our binary or 0, 1 valued values. And then we need to say end. Okay, so let's show a linear combination of variables. So that takes instance string. Interpolate. Is that the right list function? Intercalate. Okay, so I'm going to do that between coefficient and variable. Is that just looks like show coefficient plus variable. Okay, and then we need to do constraints. I don't know why I used C here instead of P. All right, to do that we need show bound, show the operators, equal is single equal, greater than or equal to, and less than or equal to are just normal. Normal for computer languages anyway. Okay, so that's, we can give them names if we had names. We don't, so we're going to say show linear, show bound, plus There we go. All right. It looks functional. Let's try it out. Screw it. Didn't export the constructor. There's a lot of zeros there. That's not good. Oh, because they don't. Because those are zero costs. Should I put a space in there? It'll be more legible if I put a space in there. So there's our initial constraints. One robot, no inventory. You can only build at most one robot each turn. So if we decide to yeah, that looks wrong. That's saying four times this is orc costs, but it's 4434 rather than 4232. All right, let's take a look at that. Doesn't look like less than or equal to is working. Yeah, it's not. Okay, so this is what's generating it, but this is the is it the wrong recipe? Oh, okay. I ran on the real input. All right. So that's more readable. All right. So here are our build variables, decision what to build. We say that I didn't save it. Oh, well, I need to do that. Okay, so we have to have at least enough ore to build whatever we chose for all time periods. There's the constraint for clay. These don't cost any clay, so that's why there's zeros. Yes. Each geode costs 7 obsidian, nothing else costs any obsidian. All right. What's next? So now we're saying this doesn't look right. So we're saying ore plus, oh no, this is the number of robots. We skipped it. Oh no, we did robots first. All right. So that is chaining together the number of robots from one time to the next. Good. That looks right. All right, here's expensive one. So if we started out with this amount of ore, then depending on what we built, it goes down and it goes up by the number of ore robots equals time at next. All right, that looks good. Let's pipe it to a file and see what Cplex makes of it. Okay, so we want LP. We should put that in the right file. And then nope. I printed out part 1. Missing variable name. Oh, okay. It doesn't like it that we use both signs. We need to do a minus if it's negative and a plus if it's positive. All right. It's not too bad. Okay. So we're gonna have to be smarter here. If coefficient less than 0, then blah, else plus and the coefficient. Sign constant variable. All right, yeah. Yeah, so it shouldn't be a problem having a plus first. Okay, well, we printed out part 2 as well at the end. All right. That was a lot of iterations, but not too bad. Now, I think I've run into this with I've run into this with the GLP is it doesn't actually print anything out unless you give it the output argument. Can we dump it to the screen? All right, right. Okay, it says it found 9 and it showed us I believe these are all the constraints. I was hoping to see the values of the variables. What happens if we use the other output format? Okay, that's a lot clearer. Yeah, so those are the rows. All right, here's the column names. So we can see which were built when. Okay, so objective is 9. Does that match what the example was for day 19? Yes. Good. All right, so now we need to write code. Which of these is going to be easier to parse? They're both kind of a pain in the butt. All right, let's start looking at executing system.process. Okay. A string or an integer value. So either an error, but this is IO of that. Okay. Okay, we're going to give it some arguments. We're going to give it dash dash LP and our LP file and dash 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 W. Okay. No input. Okay, so LP file. Let's take a name. So can we find the current? Let's try it just with the current working directory. So we're gonna do day 19. Name dot cplex. It doesn't work. Still very clumsy using the IO monad. Okay, so we need to get the system.process. Okay, we need to add that to our list. Process. Okay, so we need to write Cplex file. Okay, there's our boilerplate writing. Okay. What does write file look like? All right, no problem. Write file, file name, and Cplex format of P. Good. All right, so reading is going to be a little more painful. Okay. Read file fn. All right, so all we need is the objective. All right, so we need. There doesn't seem to be just find a sublist. Is prefix of. All right, sure. Filter. The first list is a prefix of the second. So I hope those are spaces. This is more difficult than it needs to be. All right. Uh, all right, we're going to take one. Okay. One, two, three, four. Those aren't rights, those are lefts. It's been so long I've forgotten what this function is called. Read. No. 0, 1, 2, 3, 4. Okay. Great. Almost there. So let's try it out. I'm worried that we lost the ID numbers along the way. Which doesn't matter if they line up. Okay. Okay, let's print them out one at a time as we go. Um, Gosh, why do for loops give me so much problems? All right. Map M underscore. Um, okay, what we ultimately need is ID times the objective function. Not sure that's what I want. Yeah, that just returns a single one. So we actually want map M, yes. From control monad. Oh, it's in prelude, all right. Okay, so this is the so run 1 given a we're working with 2 monads at once here. Okay, so we've got a recipe and a problem. So we're going to focus on the problem with file name show ID of the recipe. Recipe ID. Okay, so that's our file name. Okay, so if we get a write, and we'll return a 0. Otherwise, we return recipe ID of R times the value. Okay. All right, let's see how that works. Or if it even compiles. We didn't actually filter the lines. That's already in the IO monad, so we don't need return. Oh, exit code is not numbers. All right, so what are the exit codes? System.process. Okay, if it is not exit success. All right, we're getting close. It's also getting time where I need to go to bed, but all right. Cannot match expected type. Okay, we gotta store it in a variable before using it. And then we have a precedence problem there. Return is a function, and so it's higher precedence than multiplication. I wanted to print out the intermediate results. I forgot to do that. All right, 9 and then 12. Yes, that matches what's in the example. We get 33. All right, let's try it with our real input and see if we can pick up that star. Really? This seems very dubious to me. Some of them are 0. No wonder my program was running forever. All right, let's try this. That's the right answer. All right. Only the first three blueprints are correct. All right. Great, no problem. All right, we're going to take the first three. And we get to run for 32 minutes. Yep, I was trying to save the wrong window entirely there. Well, I wanted to give them different names. It's taking a lot longer. That's not so good. I could just leave it running overnight, I guess. It's only using one CPU. Yeah, it's doing a lot of work. It says it's somewhere between 51 and 62. I'll make this bigger, oops, so you can see it on the stream, on the screen. I set up another one running because it was only single CPU, so this won't slow it down much. So you can see what the solver does is it first pre-processes it, tries to get rid of columns that are redundant or rows that are redundant, scales it so it's well behaved. I don't really understand that well. First, it solves the problem as if it were linear rather than integer linear. And so that gives an upper bound on how well we can do with the more restricted version. And now it is narrowing down the range further. It found a integer solution and it found a bound, an upper bound, which is 7. It makes sense. Oh, 70. 70 knots. Yeah, I don't know how it got from 77 down to 70. Um, so let's see. This is the number of iterations. I don't know what the numbers on the right hand side mean. But as soon as these close, then it's found the optimal solution. I think this is the left is number of nodes to search, but internally it's doing a branch and bound like the one we didn't end up implemented. Okay, it did finish. Oops. I'm just gonna check that those 56 and 62 multiply those three together. All right. So we didn't get right. Um, okay, so we need to multiply them. So we'll do fold L1 star over the vowels. All right, let's pick up that other star. Oh no, we better fix this. We don't care about the recipe ID. Just have the value, and we're going to multiply. Would not want to go off and leave it. And of course, now it's going to do all of part one again. I'm kind of surprised that 0 is the answer. I mean, it makes somewhat sense for a programming puzzle that the hard case of it's not possible appears. I didn't think to try to optimize for that. So maybe I should have. All right. Well, I'm gonna shut the stream down. I think. Go let this run for a bit. No point all of us sitting here watching it. Although it might be interesting to see how so it thinks this one was only between 5 and 8. Interesting. And not making much progress. Oh, no. Huh, that's strange. So the second one popped up right away. All right, I am gonna shut the stream down. It's been 4 hours already. Happy holidays. Uh, have a good Christmas Eve. I will most likely be back. No, no, there we go. We got it already. Thought it would take longer. All right. Definitely a dip on day 19, but not as bad as I thought. Like 20 is actually worse. Uh, so in the third, we've done worse. Finally got it. All right. Good night. Merry Christmas.